Okay, so for this mini lesson, we're going to be talking about topographic maps. As you can see from the subtitle here, topographic maps display Earth's landscapes. So for example, we have this landscape here. So we have like an island right here surrounded by the ocean. And these lines represent the point of elevation. So let's just read our definitions here. A topographic map is a representation of land features on Earth. They are represented by these things called contour lines, and the contour lines connect points of equal elevation. So for example, we see this red line right here, and any point on this red line right here, you are at 0 feet elevation. Really two things. First of all, the 0 tells us that it is at 0 feet elevation, but also this line touches the ocean. So 0 feet will always represent sea level. And again, if we move up like this blue line right here, we see that any point on this line is at 50 feet elevation. So if you were to walk along this line, you would be at 50 feet elevation no matter what part of this line that you touched. And the same goes true for the 100, 150, 200, and so forth. Another really important thing you want to note about a topographic map is something called the contour interval. Now, the contour interval is the difference in elevation between each contour line. So if we move from the red contour line to the blue contour line, we see that there's a difference of 50 feet from 0 to 50 feet. And if we move up from the 50-foot contour line to the 100-foot contour line, there's also a difference of 50 feet. So the contour interval for this map is 50 feet. So one of the most important things you want to note with a topographic map is that no matter where you are on this map, the gradient is different. And what the gradient is the amount of elevation that is gained or lost over a certain distance. Now you can find this equation in your reference table on page 1. So for this example, we're going to get the gradient between points C and D. And we're going to use that, or we're going to use this equation to do that. Gradient equals change in field value divided by distance. Now, in this case, the change in field value is going to be the difference in elevation between C and D. So first we have to locate points C and D, and we are going to get a difference in elevation so that we see that point C is on the 50-foot contour line, and we see that point D is on the 200-foot contour line. So we can put that into our equation and say that the change in field value is 200 minus 50 feet. It's very important that you put the units down here, so when we solve our equation, the units will be correct. You always want to put the highest number first. You want an absolute difference in elevation between points C and D. So now we have to take care of this distance part. And to do that, we're going to use our scale down here. So when you actually do this, you're going to have a piece of paper and line it up on your topographic map. When you do that, you're going to line your piece of paper straight on this line between points C and D, or whatever gradient you are going to get for your particular map, and you're going to mark with a pen or pencil on your piece of paper this point at C, and you're going to mark with a pen on this point D. And once you've done that, now you can move that piece of paper down to your scale and see the distance there is between points C and D. And in this case, the distance between C and D is 6 miles. So we can go ahead and put that into our equation for distance. 200 minus 50 feet is 150 feet divided by 6 miles. So the gradient between points C and D is 25 feet per mile. So what that means is that if you walk from point C to point D, you are gaining 25 feet per mile in elevation. If you walk from point D to C, you are losing 25 feet per mile in elevation. One other important thing about gradient is that if you aren't trying to calculate it and you just want to kind of know where the steepest and the most shallow gradients are, you can do that very easily by just looking at the spacing in between the contour lines. Where the contour lines are closest together, that will always indicate the most steep gradient. So like a steep hill, if you're walking up this thing, would be like right here where this red circle is. Another example of a steep gradient would be here and here. And if you want the easiest route up and you want to find the most shallow or the less steep part of the mountain, you want to look for where the lines are spaced out more further apart, like right over here. The lines have nice wide spaces between them, and that's a very, very shallow gradient. So that's it for topographic maps. There is more to these, but this is a great starting point for our first lab for topographic maps.